I'm Jeff.
And I'm Steve.
We're out here looking for something that's been buried for thousands of years.
We can't tell you where we are, but we can tell you that we're the Meteorite Men.
Blazing across the night sky, they arrive without warning. Visitors from other worlds who've traveled millions of miles and now lie buried, waiting to be discovered. Steve Arnold and Jeff Notkin are driven by a single obsession: to unearth these alien visitors.
Look at that.
They are meteorite hunters.
Oh! What could be more mysterious and exciting than looking for lost bits of the universe that have landed on Earth? Oh! It's a monster.
Their quest takes them around the world, searching for rocks from deep space that hold answers to our biggest questions.
They are the oldest record of the very beginnings of our solar system.
Their mission is part science,
This might have seeded life on our planet.
Woo!
part treasure hunting,
A lot of meteorites are worth more than gold.
complete with ancient maps, secret sites, and something never seen before.
These meteorites are packed with gemstones from outer space.
You're wearing a part of creation around your neck when you're wearing this, because this is the interior of a planet.
Wow!
It's just another day's adventure for the Meteorite Men.
This is looking quite big.
Steve Arnold and Jeff Notkin are modern-day treasure hunters. Their typical morning begins like most of ours, with a commute. But today, their commute will take them deep into the heartland of America on a quest for the ultimate buried treasure, meteorites that date back to the origins of our solar system.
I became a meteorite hunter by accident. I was actually doing some research on how to do treasure hunting, and I ran across a newspaper story from 1890 where this lady had found a meteorite and had sold it to the chancellor of the University of Kansas. And I went, wow, meteorites were worth money over 100 years ago. I wonder if they're worth money today.
Steve poured through public records and found old maps of meteorite finds.
All of a sudden, I had these maps, and they were like real treasure maps. First one.
The clues on those maps led Steve to some major meteorite discoveries that were soon in demand with collectors and scientists.
Woo!
Then in 2005, while searching in a wheat field in the middle of Kansas, Steve unearthed a record-setting 1,430-pounder. The media dubbed it the $1 Million Rock.
It was like, oh my God, this is the day my life has just changed.
Steve's meteorite hunting partner is Jeff Notkin. Jeff got hooked on outer space as a child in London.
I got permission from my parents to skip school and stay home and watch the Apollo moon landings on television.
It's one small step for man, one giant leap for mankind.
I was probably 6 or 7, and my mother took me to the Geological Museum in London. There's this dark, moody, ominous room, and it's full of meteorites. I was just stunned. I mean, these things were actually from out there. These weren't rocks from Earth. These were visitors from space. And they let me put my hands on these meteorites, and it was chilling. And from that moment on, I was bitten, and I never recovered from that bite.
Steve and Jeff met in 1997 on a meteorite hunting expedition in Chile. They've been hunting as a team ever since. Although they've traveled the world together and share the same birthday, the similarities end there.
I grew up a football star in Kansas, and he was a punk rock star in London.
Steve's conservative.
He is very liberal. Jeff's a neat freak. Some would say I'm sloppy.
I am a vegetarian.
And I'm a strict carnivore.
The thing we have in common is we love getting out into the wild places and digging for space rocks.
Today, Jeff and Steve are heading for Brenham, Kansas, where several thousand years ago, a large meteorite had the same destination. Their goal is to find remnants of that ancient rock.
Well, look
Look at what the wind blew in. How you doing?
It was a tornado, actually.
Yeah.
I saw Dorothy on my way, and
And Toto?
I didn't see the dog, but she was standing.
Pieces of the Brenham meteorite have been unearthed in these fields for more than a century. It was thought that everything had been recovered. That is, until Steve found his record-setting rock here.
Everyone thought there can't possibly be any more meteorites there because people have been hunting since the 1880s. There probably isn't even a pea-sized piece left. That's what everyone thought except Steve. He just rocked the meteorite world. The biggest Brenham ever found.
Inspired by the big find, Steve and Jeff believe that some of the largest pieces of the meteorite are still deep underground, beyond the scope of traditional detection equipment.
Ready to find some rocks?
All right, let's go, let's go. I want to see.
So they've come with an arsenal of tools.
I saw.
Because most meteorites have a high iron content, metal detectors are essential. Steve and Jeff bring several.
This is one of my favorite metal detectors. It doesn't have a very big range, but it's really good for finding smaller targets or for pinpointing larger targets when you're close to them.
All metal detectors work on the same basic principle. A signal is sent through a coil and broadcast into the ground as an electromagnetic field. Encountering metallic objects alters that field, and that change in frequency is heard on a speaker.
There's our signal. That little beep tells us we found a metallic object. Unfortunately, by the time I get up to here, a couple of feet away, can't see the target anymore.
This detector, you'll notice the coil is really big. And this allows us to go even deeper.
But for meteorites even deeper underground, you need a detector with an even bigger coil.
This is what we call the 1 meter coil. May look completely different from the other detectors, but basically it's the same thing. Here's the control box, sends a signal down this wire, and here's the coil that sends our electromagnetic pulse down into the ground looking for targets. This piece of equipment will find a meteorite 5, 6, 7, 8 feet underground if it's a large target. We love it.
But Steve and Jeff need to think even bigger. So Steve designed the ultimate meteorite hunting weapon.
This is probably kind of how the Wright brothers assembled their first airplane.
Okay, let's lift this over. You don't go to your favorite mega store and go to the meteorite hunting aisle and find the stuff you need to hunt.
How do these things get so tangled up on their own?
To search large areas, Steve envisioned a giant metal detector that could be pulled by a truck or an ATV.
If you want to find the big stuff, you gotta go big.
His solution was a sled made of PVC pipe, big enough to carry a metal detecting coil 50 feet long.
Oh yeah, don't forget the flag. Could we put a small English flag up there as well?
Because there can't be any metal near the coil, plastic zip ties and duct tape are used to fasten it to the sled.
Over the back.
Fully assembled, the detector measures 126 square feet and can detect meteorites 10 to 20 feet deep.
Oh, I feel like Charlton Heston and Ben-Hur. In the old days, hunters would walk a field like this using the little handheld detectors. It's hundreds of acres. You could spend your whole life doing it. With this unit that Steve designed himself, we can cover a huge area like this in a couple of days.
But even with the best equipment, knowing where to search for the hidden rocks comes down to understanding just how the meteorite first made its entry into our atmosphere.
Now, when an asteroid comes into the Earth's atmosphere, it usually will break up. The force on the mass is tremendous. It breaks up into multiple pieces. So the rock will come in, and as it comes in, the smaller pieces start to drop off, but the larger pieces with more inertia will go further.
The landing zone is called a strewn field because the meteorites are literally strewn along a path by the disintegrating meteor. At Brenham, that path spreads out over 9 square miles.
In this particular place, we have 125 years of documented meteorite recoveries, and so what we do is go back into the old records and find out where other pieces have been found.
So we put all that intelligence together into a map. The yellow is the approximate boundary of the strewn field, and the red stars are some of the meteorites that have been found. The biggest star right here is the largest Brenham meteorite, which was found by Steve a couple of years ago in that field just over there. So we're really close.
Their hunch is that other massive pieces followed the same trajectory as Steve's large find. So their search today begins in a sprawling field adjacent to that area. But the odds are still stacked against them. They're trying to find rocks that traveled millions of miles and have been buried for thousands of years, somewhere under 9 square miles of farmland.
You have to be prepared to really put in a lot of time if you want to be a meteorite hunter. It's not the kind of thing where you can say, gee, I'm gonna go out and find a meteorite and find one on your first day. It's just not gonna happen. We've gone out in the field sometimes for weeks at a time, 10 hours a day, 5 days, and we don't find anything.
But today, just a few hours into the search, the huge detector picks up a strong signal, which could be the beacon of a meteorite buried deep beneath the surface.
Right here, Jeff, I think. There we go.
Using the 1-meter coil, they zero in on their target.
Oh, I like the sound of that.
It's a pretty good sized target. Really encouraging, really strong. Okay, right there.
The target is right in the sweet spot of the strewn field, not far from where Steve found the 1,400-pounder.
Just down there is where you found the monster.
Yes,
It's
right.
almost perfectly aligned, right? Right in the middle of the
And
big
it sounds
zone.
deep.
I wanted to get my hand.
Yeah, yeah. You start digging, I'm calling the backhoe, all right?
Okay, Dan, we did an exact pinpoint. That flag's right on top of it.
Dan Woods, a Brenham local, has been helping Steve dig for meteorites for years.
Dan is as good as it gets on the backhoe. There's nobody I'd trust more to get a rock out of the hole than Dan.
There you go.
It's sitting down here where it could be 1,500, 2,000 pounds. Who knows? Who knows?
If Steve's prediction is right, they could be sitting on the biggest Brenham find ever.
Just so you know.
They carefully dig trenches on both sides of the target and use the small detectors to pinpoint its exact location.
I'm getting it, but it's stronger on that side, and that side's deeper, so
Okay.
we're probably still further down.
Okay.
Yeah, the deeper the target is, the bigger it has to be in order for our detectors to see it. So the anticipation's building there.
Dan, go ahead and a little more. If you bump into something, stop. Okay.
Okay, keep going. I don't see anything yet. Getting down to the clay. That's a good sign.
There's a certain point below which you're almost guaranteed to have something, because man-made materials, debris, farm implements, cast-off bits of junk tends to be in about the top 3 feet. So when you start to get down into that dense clay layer, there's not going to be anything human-made down there unless it was purposefully buried, and that's pretty unlikely in the middle of a field in Kansas. There's something in there.
Oh. Oh. What is it?
That doesn't look very encouraging.
No, it doesn't. Let's take a little bit off of here. And Dan, let's go slowly right here on the top. Ooh, 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 ooh.
It's a little
Wow. Looks like more of the same.
weird. What the hell is that?
It looks like a 55-gallon drum. Oh, look, and a barrel inside a barrel. How lucky can we get? 2 barrels in 1 hole.
It's a double meteorong.
In the meteorite world, we have what are called meteorites, and then what we affectionately call meteorongs. Now, a meteorong could be just a black rock. It can be an old horseshoe or a pair of pliers, or it's amazing the different things that are found out in the field.
Look at that.
That comes with the territory. You got to find where they're not to make sure you've really covered all the places that they could be.
That was a really good signal. And it's sitting in a spot where it could have been a monster. And it could have been a ton or more. And it wasn't. What can we get for that on eBay? Oh, well. All in a day's work. We know another spot where there's not a meteorite. I get sick of saying that.
Steve and Jeff redoubled their efforts. They're still convinced that these fields contain undiscovered pieces of the famous Brenham meteorite that broke up as it entered the atmosphere several thousand years ago. But despite the common image of the burning meteorite crashing to Earth, the reality is far different.
Contrary to popular belief, meteorites are not burning hot when they hit the Earth. People that have been lucky enough to get there shortly after the fall and touch it or pick it up report that they're either cold or slightly warm to the touch.
What we see as a fireball is still miles above the Earth. Most meteorites burn out well before they make impact.
Although they may hit our atmosphere at many thousands of miles per hour, most meteorites don't make craters. Atmospheric braking slows them down. A typical meteorite might hit the surface of the Earth at a few hundred miles per hour, same speed as a golf ball.
2 more hours of searching and still nothing. Suddenly, the metal detector is triggered to life. It's another signal, even stronger than the last one. And less than a mile from where they uncovered the barrel.
We're getting a longer signal this way than this way.
Yeah.
Backhoe? All right. I'm not guessing this time.
Yeah, it doesn't seem to pay when we guess. We end up with trash.
It just embarrasses you.
Yeah. By pointing the detector down in the corner, we see that it's still probably deeper. And the signal is a lot louder on this side. So the target's a little closer to that.
You're good. Deeper's always good.
The further underground we go, the older the layers are. And so it's time travel. 250 years ago, there wouldn't have been anyone out here that knew how to work iron and steel. So once we get below that time period, there's nothing human anymore. The only things down there may be extraterrestrial.
Oh, wow. Right here.
Okay, let's jump in the hole with the shovels, dig it out by hand.
Yeah, we're getting awfully
close.
I don't
I'm
want
getting
to knock
nervous.
the top off.
Oh.
What's happened is we've just hit this little pocket, and it looks like there's some little crystals in there, so we could have just encountered the outer corroded layer of a meteorite. So we're taking it real easy.
There it is.
Oh yeah, the magnet's sticking right through the ground. These meteorites contain a great deal of iron, so when we get right on top of the target, we'll put a very powerful rare earth magnet down in there to see if we can connect with the surface.
Reaching into that hole and scraping that dirt off the first time and seeing that little bit sticking up out of the dirt and knowing that it's from outer space. It's just shocking. Every time I still get chills. I go, wow, it really is. It's not a pipe or a horseshoe or a plow blade. It's the real thing.
Oh, wow! Oh. Wow, it's a nice rounded shape. This is looking quite big.
It looks like the metal is rusted into the soil. Well,
Look at that. The outer layer of this meteorite's corroded, and pieces are just flaking right off.
looks like there's a crystal in it.
Oh.
That crystal indicates that this is a pallasite, an extremely rare type of meteorite.
A pallasite is a stony iron meteorite that's made up of roughly equal parts of iron, nickel, and olivine, also known as the gemstone peridot.
It's pretty substantial.
Pallasites originated several billion years ago when the core of an asteroid or planet was molten iron and nickel. It's on the outside edge of that core where pallasites form their unique mixture of elements.
If you cut them thin, they'll become translucent. You can hold them up and light will come through, and it's like a cosmic stained glass window.
The light shines through and you see these crystals, these gorgeous, glorious, brilliantly colored crystals.
Think of it like chocolate chips being mixed into cookie dough. In some areas, you have higher concentration of chocolate chips. In others, you may not get any. And so the crystals are like the chocolate chips, the cosmic cookie. So the way the cookie crumbled, sometimes they're all solid iron in an area that the crystals just didn't get assimilated or distributed in the formation. And then others are more evenly. And so we're seeing some crystals, but we're also seeing some oxidation. Oh my! Oh! Jeff, look at it. Look at it.
It's a monster.
This amazing bit of some planet that's billions of years old, that burned in our atmosphere and fell in the mud and sat there for thousands of years and nobody knew that it was there.
It's too heavy to lift, and that's really good news.
We find it, we pull it out. It's something you don't forget. It's an amazing moment.
Wow. That is a chunk.
Not only has it been reintroduced to sunlight, but we are the first humans ever to see this visitor from outer space.
At 230 pounds, this pallasite ranks in the top 1% of all meteorite finds in the world.
It's kind of a special moment for us.
And proves that Steve and Jeff's hunch was right about there being more meteorites in the Brenham Strewn field. They're now convinced that there are even more treasures to uncover here, and they're determined to get to them first. Kansas is a meteorite hunter's mecca with 140 documented meteorite falls, more per square mile than any other place in the U.S. Although scientists don't know why so many meteorites end up in Kansas, they have a pretty good idea of where they started their journey.
Most specialists agree that most or all meteorites were once part of the asteroid belt between Mars and Jupiter in our own solar system. So a large planet or asteroid breaks apart for whatever reason. Perhaps it collided with another one. Things crash into each other up there in the asteroid belt all the time, apparently. There are billions of pieces of cosmic debris wandering around up there in space. And every now and then, our planet bumps into one of them.
The meteorite fall in Brenham has been heavily searched for decades. But Steve and Jeff still believe the area is rich with potential meteorites, if you know where to look. Steve and Jeff know where to look, but they still have to cover hundreds of acres. How do they keep track of where they've been? Their secret is industrial-strength GPS.
When I cover acres and acres of ground, I want to make sure I get every square inch covered. What I found out was farmers have already done this. They've used GPS technology to direct their tractors. So I've adapted this technology for hunting for meteorites. A car GPS might get you within a couple hundred feet. This is going to get us within a couple of inches. I'll set it with a path on here, and then I follow it, and then it tells me to turn around, and within inches, I can come back the other direction. This screen will give me an arrow that will point me in the direction I need to go. When I get really close, I have red lights up on the bar that will tell me when I'm too far off. If I'm centered perfectly, I get 3 good green lights up there. So I could be a little bit blurry on this, but still focusing on where I'm going, and it keeps me on track. This enables me to make sure I get every bit of it covered.
We get a little more specific with these smaller handheld units to exactly pinpoint the find. So it helps us go back, locate it, dig it up, but more than that, it helps us compile very accurate strewn field data, because we can then take the latitude and longitude and our altitude, and all of that information helps us compile the most accurate strewn field map that we can.
After searching 30 more acres, they encounter another strong target.
We get the tractor in?
Let's go, Dan.
Just a few minutes ago, this detector got nothing. Now we got a solid target there, so we're getting closer.
Farmer Denny Ross keeps a close eye on the dig. His family owns the land, and Steve approached him for permission to search.
He drew up a contract, and we'd split the share of one if he sold one and found it sold. Oh, just hit something pretty big, I think.
That was it, okay. Let's get a shovel.
Right there. Oh, look how round it is.
To their amazement, it looks like another meteorite.
Wow. We've just exposed a tiny bit of it, and what always makes us really happy is when the magnet sticks.
Look how deep it is.
Wow. Yeah. That's one of the really great moments when you uncover a little bit of it, and you go, oh yeah, it really is a meteorite. And then you uncover a bit more, and then some mud falls off, and you go, oh wow, it's actually that big.
We got a big one.
1, 2, 3.
Woo!
At 273 pounds, this find is even larger than the first.
2 for 3. It's not bad odds, actually, in this game.
Both are in the top 1% of all meteorite discoveries in the world.
This is the land of the giants. And it's almost like going on a safari at Jurassic Park. It's just, this is about as good as it can get.
Agreed. The only thing I'm a little concerned about is how we're going to get it out of the field.
Yeah, no kidding.
The odds of finding 2 meteorites this large on one expedition is like winning the lottery twice. Each rock could bring in $100,000 or more. The next destination for these rocks will most likely be a private collection, museum, or research facility. In fact, the scientists who study meteorites rely on hunters like Steve and Jeff to provide samples.
We donate a piece of every new specimen that's found to science, and they're able to get a lot of information. They're able to classify the rock as to what type it is.
It benefits everybody because they get a sample, a specimen to work with, and we get the benefit of their expertise, of their knowledge.
So with more than 500 pounds of meteorites in the back seat, Steve and Jeff take to the highway. Their 1,000-mile journey ends at Arizona State University, home of one of the top meteorite studies programs in the nation. Before entering the research center, they give their space rocks a good cleaning and remove a sample slice to be used for testing. Lawrence Garvey, the manager of the school's meteorite collection, takes the sample and preps it to be analyzed.
We're just going to do a very rough polish.
ASU's I-beam lab has a particle accelerator. It's one of the few instruments that can quickly determine if Steve and Jeff's find is extraterrestrial or just an ordinary rock from Kansas.
Okay, let's start a spectrum right here.
It does it by firing a beam of protons into a solid target. Based on the energy released by the collision, scientists can determine the exact composition of the rock atom by atom. They are looking for an abundance of nickel and iron, a mix rarely found in rocks on Earth.
In less than 10 seconds, and I can already see the nickel peak, these 2 peaks right here. The 2 big peaks right next to it are iron, and not much else to look at. So this metallic part is quite pure.
The analysis clearly shows that the dominant element is iron, with a significant presence of 8 to 15% nickel. Overwhelming evidence that this rock is not from our planet.
We see that nickel peak to begin to show up. We know we're onto something because nickel is the tell for us. That's a real classic meteorite spectrum right there.
That's what I like to hear. Classic meteorite spectrum.
Tests also confirmed that the pieces Steve and Jeff found were part of the historic Brenham meteorite.
We analyzed their piece and we compared it with a piece of Brenham that we have in our collection, and they matched up in terms of the content of nickel in these samples.
Professor Meenakshi Wadhwa, who directs the ASU Meteorite Studies program, is an analytical geochemist.
I want you to guess which one of these is a meteorite and which one's a meteorong.
My work focuses on trying to understand when the planets are forming and how the planets are forming. And you can do that by studying meteorites because they are the oldest record that we have of the very beginnings of our solar system.
In fact, ASU has a collection that includes meteorites that were formed even before our solar system.
These were probably the very first solids to form 4.5 billion years ago. They even contain particles that actually formed around other stars before our sun was even formed. They're basically stardust.
In your hand, you're holding the oldest matter that anyone on our planet could possibly touch with their hand.
Exactly, 4.5 billion years old and older, as I said.
Looks great for its age.
Yes.
Holding up quite well.
These rocks basically have a story to tell, and as we improve our analytical techniques, there'll be more things that we can learn from them.
Tucked away in a drawer is one of the rarest meteorites in the university's collection, a small rock that scientists hope will answer some big questions.
Famous Murchison. Does it really smell?
It does. You want to smell it?
Wow, it's the smell of outer space.
It's actually got a lot of organic materials in it.
The Murchison meteorite is classified as a carbonaceous chondrite, a type of stony meteorite containing the organic element carbon. They are the most primitive and unaltered type of meteorite known.
It's got, yeah, it's still got some of the...
clean that up, would you?
Yeah, it's still got some of the dirt on it.
Scientists believe this ancient rock may hold answers to the mystery of how life on Earth began.
Certain types of meteorites, like the carbonaceous chondrite, most likely did bring the organic materials from which life could have gotten started on our own planet.
So we're looking at one of our ancestors there, possibly.
Well, you know, it
Kind of a
could be
cousin.
the raw
We didn't
materials.
descend
The raw
from it.
materials
Okay,
for,
all right.
yeah, for life.
No wonder we're so into meteorites. We're descended from them.
Well, maybe you are.
Today, they're heading back out to the field to a site they simply call Alpha. They're keeping the exact location under wraps because they believe there are meteorites here that contain something rare and extremely valuable.
Turn off the cameras.
Before filming is allowed on the site, the camera crew must sign confidentiality agreements promising not to reveal the location.
Welcome to what we call the Alpha Site.
This is one of our favorite meteorite hunting grounds. Come on, Steve. Let's go find some meteorites.
Like Brenham, the Alpha site is a location where meteorites have been found in the past. But unlike Brenham, which had been searched heavily, there are very few documented finds at Alpha. In fact, there was no existing strewn field map to give them an idea of how far the fall extended, so they had to make their own. In essence, they are hunting in virgin territory.
We're looking at about, what, 7 miles now?
Yeah, maybe a little more.
The exact location where we are today is right on the center line of the strewn field. It's not an actual existing landmark, but it is a theoretical line that Steve plotted through the known area containing all meteorite finds from this fall.
But there's never a guarantee. And here at Alpha, it's even more of a shot in the dark because of the limited historical records.
Steve, it's really loud. It sounds near the surface.
Please scratch around, make sure it's something right or something wrong.
Okay. Metal post or something.
What'd you find?
I don't even know.
Whoa, I've got something over here. I bet it's just a piece of old farm equipment.
You know, Babe Ruth was the home run king, but he was also the strikeout king. And so you have to be willing to strike out a lot.
Well, hey, you add that to the collection, I guess.
It's kind of cool, actually.
Certainly iron.
Didn't you say this was the best bit of the strewn field?
Jeff, if it was easy, everyone would be doing it.
We got a monster target here.
That's a 2 shovel signal.
I think you're right.
Like Forrest Gump's mom said, meteorite hunting's like a box of chocolates. You never know what you're gonna get.
It can't be terribly deep, or it wouldn't have. Uh-oh. Uh-oh.
That's not a meteorite.
Wow! What a signal!
It's an iron snake. Look at the size of that chain. You could tie the Queen Mary down with that. Oof. Well, we really thought we had one there. Toss that in the back of the truck and see what else we can come up with. Hopefully something a little older than this. Watch that. There's some really big boulders sticking out at the side. They'll make toast out of the detector. I'm sure you've seen them, but just take it easy.
Roger that.
Not that you're scared of a few boulders or anything like that. We hardly ever seem to have a whole day where something doesn't go wrong.
And when the giant metal detector goes down, it brings the search to a halt.
You broke it again by driving too fast. Sometimes it'll just be a minor thing. We might break one of the struts or a small piece fall off. That's easy to fix. But when one of the big struts breaks, it can be a real pain in the neck.
It's a never-ending process.
This one's cracked as well. The more it breaks, the more a gargantuan assembly it becomes.
Grab a couple paper towels. Set that down now. Go back there. Okay, hold that there.
I think Steve likes to think of me as his butler. Here,
Hold that.
Jeff, can you clean this? Jeff, can you hand me that saw? Jeff, can you hold this pipe? So it's not exactly what you'd call high-tech work, but the perks are very good. Steve's truck is one of the messiest things I've ever seen. It's a kind of collection of random garbage. Is this your filing cabinet back here? Rusty old tools, bits of clothing. Steve, I've never seen so much garbage in one truck. It's just all thrown haphazardly in there together, and then he goes,
Find the monkey wrench in the back.
it's like going through a garbage dump trying to find something. Have you ever thought of keeping all your tools in one box?
Oh, like a toolbox?
It's disgusting.
You just have to know where to look.
After losing several hours, Steve and Jeff are back on the hunt.
Hey, Jeff, that one sounded strong.
I'm gonna check it. This smaller unit has a very limited range, and the fact that I'm getting a loud signal means that it's either a very big target or it's something really close to the surface, or possibly both.
Let's see what we got here.
The few documented meteorite finds at Alpha were buried closer to the surface, so Steve and Jeff have foregone the backhoe here. Shovels and sweat should be all they need to uncover a target. It's possible that the meteorite fall at Alpha is more recent than the one at Brenham, so there has been less time for soil to build up.
Oh!
Got something?
Yeah. I don't want to hit it hard.
Oh!
Wow.
Oh,
Is it?
Oh, yeah.
Oh, yeah. Look
That
at the
looks
rust.
really good.
Dude! Finally! Look at that.
That's potentially a nice shape.
Yeah. How long have you been waiting? This rock has come from so far and has been sitting there so long, I haven't been hunting nearly as long as this guy's been traveling to get to me.
Oh, wow.
Look at that.
The latest visitor from outer space to be discovered on the Earth.
At 33 pounds, this meteorite is considerably smaller than the finds at Brenham. But the minute they pulled it out of the ground, Steve and Jeff saw something in the rock that could be far more valuable.
This meteorite contains something we've never seen in a meteorite.
Here's our newest find, and as he's a bit of a VIP, he gets to ride up front with me. Place of honor.
But as they head out to examine their latest find, they hit another strong signal.
Whoa. That was something. You grabbed 2 detectors and no shovels.
What can I tell you? I'm a gearhead.
Finding 2 of the rare alpha rocks in one day is extremely unlikely, but Steve and Jeff still check out every signal.
It's digging time. Again.
Even after all these years, not for 1 minute does it become humdrum.
It's like digging through tarmac. Man, this is hard digging. So much for shallow targets at Alpha.
Let's keep digging.
I never go, oh, do we have to dig up another meteorite? How tiresome.
This could be an extraterrestrial visitor down here. Resting's not allowed. To go anywhere and even find one tiny meteorite is a great achievement.
Ooh.
Yeah, there's definitely something down there. Space is huge. Those fragments of debris from the asteroid belt could have gone anywhere. Away from Earth, into the sun, a million billion possibilities. A piece encounters the Earth's atmosphere, it doesn't melt, burn up completely. It falls to Earth, it doesn't fall in the ocean, it doesn't fall in the Arctic or in the rainforests. It actually lands somewhere where we might one day find it. It's definitely sticking to a magnet.
Wow. It looks like a corner of a meteorite. I don't think it's a Meteorong.
We have overcome literally astronomical odds to find one.
We may need to dig a fairly large hole to get this guy out.
Exhausted but exhilarated, they're now in a flat-out race to dig it out before the sun sets.
There's a nice little corner exposed. We might be able to lever it up from that.
Oh!
It's moving a little bit. That was a superhuman effort. Look, it's kind of wedge-shaped.
Oh! It looks like a spaceship.
It is a monster.
Look at that. Look at that!
What a privilege it is to be the first humans ever to see this amazing thing that traveled millions of miles, to see us, to be here.
Not only a visitor from outer space, but a very substantial one.
At 109 pounds, this find is more than 3 times the size of the first Alpha rock. And upon closer examination, Steve and Jeff are even more excited about the meteorites they've uncovered here.
It's just covered in all these little indentations. It's so unusual.
But it's what's inside those indentations that sets the Alpha meteorites apart.
It is packed with olivine crystals.
The mineral olivine, named for its olive green color, is commonly found on Earth. In gem form, it's known as peridot, the August birthstone. But meteorites containing olivine are extremely rare. And what makes Steve and Jeff's find so amazing is that much of the olivine has made the tumultuous journey to Earth without shattering.
For example, the Brenham meteorite. If you look at a slice of Brenham, all the crystals are shattered in it.
But the crystals in the Alpha meteorites are remarkably clear and unbroken.
Harder and harder to find.
For Steve and Jeff, that means that the rocks they've been finding at Alpha may soon be coveted by more than just scientists and collectors.
What's exciting is that we're finding quite a few of these crystals are gem quality. And so we are able to facet gemstones out of them.
Steve sent one of the faceted stones to gemologist John Koivula, an expert on peridot from meteorites.
It's the only extraterrestrial gem we have. A good portion of the asteroid belt consists of rocks, basically, and then a few have the olivine grains. So it's a rarity to begin with, right in the asteroid belt. And how many of them are going to actually hit the Earth? Not many. So when one does hit, it's a rare occurrence.
In the world of gems, rare equals pricey. Peridot found on Earth goes for about $60 a carat, while peridot from meteorites sells for more than $1,000 a carat.
This is one of Steve Arnold's stones. Actually, this is very big for an extraterrestrial peridot, and it's very nice. So basically, you're wearing a part of creation around your neck when you're wearing this, because this is the interior of a planet. That's what it is. It's a piece of an interior of a planet.
When you think about it, these meteorites are literally packed with gemstones from outer space.
So how can the GIA tell if a gemstone is from outer space or from right here on Earth? Experts like Koivula can look for microscopic details inside the gems.
The inclusions you find in the extraterrestrial peridots are shock remnants, and they form along structural planes. This is multiple cleavages.
And terrestrial peridot inclusions have a distinctly different look under the microscope.
This is the relatively common inclusion in a terrestrial peridot, one from planet Earth.
But what if the source of peridot can't be distinguished by looking under a microscope?
Then we would rely on the chemical profiles created by the mass spectrometer.
A mass spectrometer works by placing a sample in an airtight chamber, and a laser vaporizes small bits of the sample. The flashing circle of light is the laser firing. The vaporized material is then fed into a plasma torch, a jet of gas as hot as the surface of the sun. The mass spectrometer sorts out the basic chemical elements and creates a fingerprint that is unique for extraterrestrial gemstones like peridot.
What's even more amazing is the discovery made by accident. The alpha stones, when cut and polished, display chatoyance, the mysterious light within the stone, similar to light reflecting in a cat's eye.
Chatoyance has never been seen in a meteorite before. Steve's and Jeff's discovery opens up a new scientific question of why this effect has only appeared in the alpha stones, a question that may help unlock some of the many mysteries carried to Earth by these extraterrestrial visitors. The Meteorite Men are a new breed of space explorer, seeking out hidden traces of our cosmic past buried deep beneath the surface of our planet. And their quest is just beginning.
There are big meteorites out there waiting to be found. There are meteorites out there that probably landed yesterday that no one's seen, and there are meteorites out there that landed 1,000 years ago that nobody's seen. Come on, Steve, let's go find some meteorites.
Let's go.
We as humans are fascinated by mysteries, particularly the really big mysteries, like what is our place in the universe?
Meteorites tell us something about the very deep past, 4.5 billion years ago when our solar system was just forming.
It's kind of this unending quest of chasing down knowledge.
But more than that, it's a chance for us to hold in our hand a little bit of the substance of space that has, against all odds, found its way to our planet.
Hey, Jeff, sounds like we got something here.